Morning friends. Today we are going to continue the next part of the next lesson of the unit 2 of the paper 1 aberrations. Definition of aberration will come for the MCQ purpose. You should know the aberrations. Generally, in case of the lens we have to talk. Ideal lens is one which gives the image of the point object as a point, but in practice no lens is perfect. Hence the image of the point object is obtained as a patch. Thus the deviation from the actual size, shape and the portion of an image as calculated from the known simple equation are called as the aberration produced by the lens. Okay. Then said the scientist named Seidel was the first scientist in 1980 85 55 studied the behavior of the lens when a aperture of the lens is large. Objects cover a wide field of view that is not only paraxial but oblique as well as when large angle pencil of light are incident on it. These deviations are called the Seidel or same monochromatic aberrations of lens because they exist even if monochromatic beam of light is used. Due to prismatic action of a lens, when the incident light is polychromatic, the aberration produced due to variation of the refractive index with the wavelength of light are called chromatic aberration. That monochromatic aberration and chromatic aberration, that is when the polychromatic light is used, and such aberrations are called as the chromatic, and when the monochromatic light is used and gives the aberration is called as the monochromatic aberration. It may come for the MCQs. In short, aberration is the departures of the real image from the ideal image. Aberration is what? Departures of real images from the ideal image is in respect of the actual size, shape and the position. Aberrations are divided in two types, monochromatic and chromatic. Depicts occurs due to wide angle incidence and the peripheral incidence which occurs even with the monochromatic light called the monochromatic aberration, and the aberration occurs due to dispersion of light called the chromatic aberration. It occurs with light that contains at least two wavelengths. Monochromatic aberration divided into five types: spherical aberration, astigmatism, astigmatism, curvature of the field, and distortion. Spherical aberration. Here again, these things will come in the MCQ. Spherical aberration, you can see here in the sphere, you can see that a lens is thus unable to bring all rays to common focus. This defect is called as a spherical aberration. If the spectra is placed reducing spherical aberration, you can reduce or minimize or eliminate the spherical aberration by the following method. Spherical aberration can be minimized by using a stops which reduce the effective lens aperture. The stops used can be such that it either permits the paraxial rays of light or the marginal rays of the light. However, as the amount of the light passing through the lens is reduced, correspondingly the image appears less bright. The stop reduces the effective aperture of the lens, but at defined image is obtained. Then the spherical aberration minimum for the lens which is biconvex or biconcave, and the radius of curvature of surface facing the incident light is 1/6 the radius of the curvature of the other face. That's the second condition. To reduce the spherical aberration, plano-convex lenses are used with the surface of the lens facing the incident or emergent light, whichever is more parallel to the spherical aberration can also be reduced by using two plano-convex lenses separated by the distance of equal to difference, that d is equal to focal length, their focal length, that is d is equal to f1 minus f2. Spherical aberration can be reduced by using a suitable combination of the convex and the concave lenses. Then the distortion, variation of the magnification produced by lens for the different axial difference result in the aberration called the distortion. Again, there are two types: pin cushion distortion and the barrel shaped distortion. You can see here pin cushion distortion is shown here, and the barrel shaped that distortion is shown here. Two diagrams are shown. The magnification increases increasing axial distance, and the image of the object appears as shown in the figure B, whereas this particular thing is the barrel shaped. To eliminate distortion, a stop is placed between two symmetrical lenses so that the pin cushion distortion produced by the first lens is compensated by the barrel shaped distortion produced by the second lens. The chromatic aberration, the refractive index of the material of the lens is different for the different wavelengths, means for the colors. Focal length of the lens is given by this equation as already we see. Lens maker formula: 1 upon fn is equal to mu minus 1, 1 upon r1 minus 1 upon r2. Then focal length of the given lens is different for the different color. As a result, when a point of object emitting white light is kept in front of the lens, the image form will not be the single point image. For different color, the image will be formed at different point. This defect is called as the chromatic aberration. Here you can see in the diagram, then the axial chromatic diagram. Chromatic aberration can be minimized by keeping the two lenses separated by the finite distance or in contact with each other. Use one convex and the other concave lens. Lenses made up by the different materials. Circle of least confusion for a point object illuminated by white light and is situated on the axis of the lens. Colored images are formed along the axis. The violet image is nearest the lens and the red image is farthest. In between the two images, if the screen is placed at the position AB, the image of the least chromatic aberration is formed. The circular patch with diameter AB is called the circle of the least confusion. This is about the aberration. Some part remaining part will see in the next lecture. Thank you.